let's talk about different categories. So we have the Best Startup Award, that is the Investor's Choice. So we had this great pitch session on Tuesday with 8 different startups that were pitching in front of a crowd of investors and journalists. And this is the award for the most promising startup in terms of investment, awarded by the jury of the FIRA USA investors. The second category is the Best FIRA USA Robots. This is the participants' choice. The robots showcasing at FIRA USA that received the most votes from the participants, and that is awarded by FIRA. And finally, but not least, the Farm Robotics Challenge winners. This is the awards for the best college teams for the Farm Robotics Challenge organized by UC A&R and AIFS. So, let's start now with the best startup, the investor's choice. Let's welcome on stage Walt Duflock and Bijoy Shah from the judges.
Oh, this one? Okay. I'll use this. So let's walk through the judges, the investor judges that selected this. It's Alex from Agco Ventures. It's Trevor from Food Bites by Rabobank. It's Bijoy from Fulcrum. It's Shauna from Colterra, Connie from Farmhand, and Michael Rose from Mixing Bowl. So big thank you to those guys for sitting through this and evaluating everybody and giving us the big drum roll, please. The award winner is? Sorry, first last year. So Adam, are you in the room? There he is. Everyone give last year's award winner a hand. Year one. Been watching Adam, been working with Adam for a while now, and I'll tell you, he continues to make a lot of progress, most recently at the Cal Poly Strawberry Days, working with some great strawberry growers, making some great progress, so congrats on last year. I know this year's been a blast, and continued progress. Well done. So with that, we had 8 startup pitches that we had for the pitch day, which seems like years ago, but was only Tuesday, right? So we had Harvested Robotics joining us from India. We had Amos Power with their electric tractor from Iowa. We had Agricola AI from Spain. We had Oddbot from the Netherlands. Elemental Agronomy from Colorado. The Smart Machine Company from New Zealand. Barn Owl Precision Agriculture from Colorado, and Pixel Farming Robotics from the Netherlands. So those were our 8 contestants that pitched on Tuesday. And next slide will show our criteria. We had 6 criteria for the judges, very quantitatively based. It's the only way to do these is to score them. Unique selling proposition was key. Market opportunity was key. Business model was key. And then management team, the presentation itself, and the impact on ESG. Those were the 6 criteria that the 8 judges looked at to pick a winner out of the list. And so with that, the best startup for 2024 Pitch Day is Elemental. Well done, team. So come on up. We'll welcome you up for an award, and we will get a quick photo. Come on up. Want the photo here? Yeah. So come on up. We'll get you in the middle. Bijoy and I on the side. You did all the work. We did it. Well done. Well done. There's our camera. Nice. Well, then thank you again. He's camera shy.
Thank you and congratulations to Elemental. So now let's go to the second category. And for this, let's welcome on stage Mayelen Cazenave, my colleague, that will be remitted this awards, 3 different levels with gold, bronze, and silver, or, on the other side, medals. Thank you.
Hi, everybody. So really happy to be here. This is the second edition that we are doing and opening the FIRA USA Awards to the public. It was very important for us to listen the participants' choice. And so among all the robot in Expo in demo, so around 40 machines, 40 machines were in competition this year. We use a app, so during the last 2 days, people were voted on the app. So we opened this on Tuesday. We closed this morning or yesterday night. So this is the public choice. So let's start. With the bronze medal goes to, yep, Nico Robotics. So the second choice, the silver medal, goes to, again, Actonomy. And last but not least, let's now talk about the finalist. The gold medal goes to, for the second time, Solevtech. Where are the guys? Okay, so now this is the last category of this award, so let's continue.
Thank you, Maya. Congratulations to the three winners. The third category, we are happy to welcome on stage Kelly Scott for the Farm Robotics Challenge. Welcome on stage.
All right, everyone. My name is Kelly Scott. I'm the Director of Corporate and Foundation Relations for UC A&R. I'm really fortunate to be able to work with the Office of Innovation, and I see Gabe smiling here. Want to give a shout out to the team, to Gabe, Hanif, Lucy, Hannah, Eric, Terry, everybody else that's involved in that, because they're all part of producing this event. I'm going to pause a little bit, and we're going to dig into what the Farm Robotics Challenge is all about, because I have a captive audience here, and I really want to sell this thing. So, and I also told the participants that we'll probably present around 12:30, so we're running ahead of schedule. So we're going to hover for a little bit, but this is all part of the plan. I'm just thrilled to be here today to represent the challenge, to recognize, celebrate all the hard work and dedication that the student teams put into this year's competition, and just to show you who participated. Oh, that's me. That's the map of who is participating this year. So we have 13 different colleges and universities. The students are both undergrad and graduate students, and I'm going to rattle off all the different majors that were part of this competition, because I think that's one of the things that makes it really cool. So hang with me here, because it's a list. Agronomy, ag engineering, all the engineerings, biological, computer, electrical, mechanical engineering. We've got computer science, we've got biosystems, we've got entomology, plant sciences, data science, human biology, physics, weed science, and of course robotics. So all those students from different disciplines are jumping into this challenge to innovate and create new things in ag tech. I'm going to say a handful of the advisors and students are able to make it out here to FIRA, but for the rest of you online, just going to wave and say hello to the live streaming folks that are watching on YouTube. As you can see, you know, we have people tuning in from all across the United States. To frame this out, for many of the teams, this journey started last fall. I want to note that while they've had months to prepare, to test, to perfect their robots. This was all done on top of the other obligations that they have in terms of studies, schoolwork, their part-time jobs, and last but not least, their social lives, which are probably a little more interesting than mine at this point, being, in their teens and early 20s. So yeah, finding that time to also dedicate all the hours, the late nights, the weekends that went into creating these projects is really worth noting for all you potential employers out there, because these students that are part of this competition, they're gonna rise above because they put in the hard work and dedication and grit to be really valuable to your companies. So that's the student part of it. The other end of it is special recognition really needs to be given to their team advisors. So this is the faculty members, the staff, the graduate students that took on leadership roles for these teams. It's their mentorship, it's their guidance, it's also your willingness to put in the extra hours and time in this that is the glue that holds these teams together to get to that final end project with their submitted project. So you're gonna see all the projects here in just a couple minutes. But before we do that, I just want to take a few minutes to show a video that we recently produced. So if you're not familiar with the challenge, I think this is a really good kind of 30,000-foot highlight of the why in terms of why are we putting energy in doing this, but also it goes right down to the granular level of the individual student experience and what it means to them. So with that, let's roll the video.
Every day, everyone is eating food 2 to 3 times a day. And that food is coming from these farms, the same farms that are, here behind you.
There is an ardent need by farmers to find solutions to labor and input-related challenges.
Here in the San Joaquin Valley, we grow the nation's fruits, nuts, and fresh vegetables, but we also face some significant challenges: climate change, drought, environmental health, and social and political issues. All of the things that we know we need to be doing for sustainability and climate change are merging with the technology.
Robotics and automation are one of those really cutting-edge innovations that is coming to us in agriculture.
The number of tasks on farm that could be automated are myriad. It's everything from preparing the ground to delivering the product. Robotics is one creative, cool way to do that. Farm Robotics Challenge creates the skeleton on which students can build an entire body. They create opportunities for innovators to grow and to try new things and to build networks with industry and with their academic advisors. That's the pathway, is through the students.
And so it's really important as we're talking about developing, introducing, trialing all this technology in the field that we train and educate and inspire the workforce of the future to get involved.
The student can get real-world experience with a robot that's driving on the field rather than writing an algorithm that lives on the cloud.
It's going to take a collaborative approach to get to that next food system. So to see kind of this crowdsourced innovation happening in such a short period of time, I'm really excited to see what we come up with.
Thanks to the Farm Robotics Challenge, we were able to push the boundaries in terms of weed detection, elimination, harvesting fruits, pollinating flowers using artificial pollination.
When you go out on the field, you take a robot to an actual farm, that's when you struggle. That's when you're like, yeah, this needs to be better. This is not really going to work for the end user.
It's very important to create as robust of systems as possible, because something that works perfectly in the lab, when you take it out into the fields, can work completely differently or can break within a matter of seconds.
There are serious companies participating and sponsoring the challenge. You just have access to an incredible network. Ultimately, I got the job because I was also able to connect with people in the industry. I was able to show these people I was prepared to be part of the workforce in the ag tech industry.
While I was participating in the Farm Robotics Challenge, I many times contacted the actual company that made this robot. I ended up getting an internship with them and gained 2 to 3 months of experience, which will help me end up getting my job in my career.
Participating in the challenge is going to transform your life.
Pretty cool, huh? Yeah, let's hear it. So this is the part that, you know, putting all this together really couldn't be done and pulled off without the support that we have from our sponsors. So I want to take a few moments to recognize them for believing in the challenge as a new event. This is, you know, we're just wrapping up the second year, so we're still getting our legs, for enabling us to produce the event and really, truly offer some great prizes and incentives to the student teams. So first off, F3 Innovate. Thank you, Priscilla, Josh, Lee, Ali, all the others at F3 that are part of this that helped really launch this challenge. And then let's go over to Beck's Hybrids. So I know Brad and Will are flying back to Indiana at this moment, but if you're tuning in and have Wi-Fi on the flight, hey guys, thanks for being a sponsor of this event. And then we have the United Soybean Board. Thank you to Paul and their board for really jumping in kind of at the last minute on this one. So we hope to develop that relationship next year, get them more involved. And then our local guys here, the California Tomato Research Institute, big thanks to Zach Bagley, his board, for supporting this and investing in workforce development. Definitely, last but not least, a huge, big, extra special thank you to our technology partner, FarmNG. And yeah, let's hear it for them. So it's FarmNG's enthusiasm in helping build this competition, in supporting the teams, the outreach, the planning, the involvement every step of the way that truly brings this all together. So thank you, Brendan. Thank you, Leanne, Nathan, Andrea, Marcelo, Guy. I met Patrick. I don't know the other names of your team members, but the whole team. Yeah, shout out to you guys. Thank you. And with that, I'd like to bring Brendan up on stage.
Okay, awesome. Well, thank you, Kelly. It's great to be here. You know, we are really, really excited to support the challenge. It's something that is kind of at the core of our beliefs and the ethos here at FarmNG. You know, the challenge wouldn't exist though without, you know, the brains behind the challenge, behind the, you know, the brains that are supporting, the hosts that are supporting it. So that's UCANR, that's Kelly, that's Steve, oh sorry, Kelly, that's Lucy, that's Hanif, and of course Gabe, the brains at APHIS, so that's Steve. So we really appreciate the partnership in this. You know, we wouldn't be able to do this without you guys, and excited for kind of the continued evolution of the challenge over the next several years here. You know, I think we are overall all here, everyone in this room is here is to think about and to solve the important challenges that we have in our food systems. And the challenge is one of those ways that we can just identify, you know, solutions and create prototypes that inspire innovation, but also develops the talent pipeline that we want to bring into the ag systems. You know, we at FarmNG really believe that if you simplify the tools, you can empower this whole next generation of talent to actually solve for the critical things that we need to evolve in our food systems. You know, improve the quality of our food, improve the way we grow our food so it's better for the environment, and of course, most importantly, make sure that the bottom lines of our farmers are kind of first and foremost. And so all of the, you know, efforts and the results of the you know, challenge participants are solving these very, very important issues in our food system. And so this is what we are involved in. We want to make these tools very simple for, you know, for students, for growers, you know, for partners, to essentially build these next generation of growing practices that are going to essentially influence the way we grow our food in the future. With that, we have, as Kelly was sharing, we had 12 schools that participated. You know, we're going to, you know, showcase the results or the projects of 9 of those schools here, and then we're going to announce the winners of the challenge. You know, I think Nathan's going to do that here after a few speeches. So anyway, thank you everyone for the hard work you've put into, hard work you've put into all the effort into the challenge, how you've supported your farmers, the opportunities and the inspiration that you're creating for the rest of us. So excited to see your work here.
Welcome to the FLORABOT demonstration. We are a team of research students specializing in precision agriculture at the Smart Systems Lab within the Department of Biosystems Engineering at Auburn University. FLORABOT is designed to autonomously navigate through nursery plant beds, collecting imagery data using a multi-camera system for plant counting and quality assessment. To run FLORABOT autonomously, we first initiate the Z data node, which collects depth images and IMU data. These data points are fed into a computer vision algorithm that determines the edges of the bed, and based on this, calculates the angular and linear velocity, which is communicated via feather to FLORABOT for navigation. These values are also used for FLORABOT's localization. We also developed a real-time deep learning-based plant tracking and counting algorithm that performs segmentation of each plant and quality assessment using a single 4K video feed from an Oak D Pro camera. During cleaning, we trim unnecessary video data and save individual files for each bed, along with corresponding GPS and IMU data. We then apply our novel image stitching algorithm to generate panoramic images of the nursery plant beds from the clean data. These panoramas serve as input for the image analysis pipeline. After generating the panoramas, the data is used for plant counting and quality assessment and have achieved 98.5% counting accuracy, with the main goal of improving nursery management by making inventory more efficient and reducing manual labor.
The robot uses a reciprocating blade mechanism designed to cut lettuce at the base, about 2 inches above the ground, without damaging the rest of the plant. The blade operates at 440 cuts per minute, powered by an electric motor with 4 ft-lbs of torque, ensuring efficient cutting. The blade height can be manually adjusted or automatically adjusted via sensors to accommodate varying lettuce heights and soil profiles. A conveyor belt system, made from food-grade rubber, then collects the lettuce heads and transports them onto a platform, and its speed is adjustable. The robot autonomously navigates between lettuce rows using GPS-based navigation with RTK correction signals and a 3D computer vision model. This enables the robot to stay on track with an accuracy of within 1 centimeter, ensuring it does not veer off into adjacent rows or cause damage to unharvested crops. The GPS system records a predetermined path, which the robot then follows autonomously during harvesting.
We detect up to 8 different kinds of fruits, including oranges, which we're picking right now. And I'm going to start it with this website that I can access from anywhere in the world. So I click Start. Now it's centering itself on orange. And it's saved the center coordinates. Next, I'm going to go and harvest it. It's twisting it off the branch. Now it deposits it in a basket.
We have the YOLO V8 computer vision model right here, trained on various weeds and crops. You can see right here, it is obtaining the bounding boxes of the 2 weeds in the image, getting the center coordinates, and converting that into steps for the stepper motors on the Core XY system that is on the Star Dog. Here's the camera. This is the Core XY. It actuates the gantry system, moves over to the weed, and you can see it sprayed.
Our robot is a precision tool designed specifically for monitoring and capturing images of artichoke plants efficiently. Built on a robust steel frame, it features adjustable cameras that slide along a horizontal beam, enabling us to take pictures from optimal angles. With its wide field of view, the camera can effectively monitor up to 60 objects simultaneously. The frame's height and stability are crucial for several reasons. First, It ensures that our cameras can capture clear, unobstructed images of the artichoke plants, regardless of their height. This is important for accurate monitoring and assessment, as the plants can easily surpass typical measurement tools.
The PhoenixBot is intended to execute sustainable weed management practices while simultaneously maintaining or enhancing crop yields.
Once out on the farm, PhoenixBot displayed remarkable progress in its autonomous crop row following. Though still in development, the system was able to navigate the row autonomously for brief periods of time. Human intervention was needed when the algorithm failed. As it drove along each row, the system showed off its ability to accurately identify and locate intruding weeds. The onboard depth camera located a weed in three-dimensional space and passed that information onto the PhoenixBot mechanical weeder. The developing mechanical weeder system navigated to the identified weed and plucked it out of the soil with minimal disruption to the soil and crops. Using video data during on-site testing, 904 out of 924 frames, or 97.8% of the frames identified all three crop rows for use in navigating, and with the exception of 11 outliers, nearly 99% of our headings visually match what seems to be the center of the crop row. When commanded during in-lab testing, the PhoenixBot mechanical weeder system moved to weeds with a mean positioning error of less than 17 millimeters.
Our developed system employs a gain-tree mechanism to move the manipulator in the XYZ directions. It also possesses 4 degrees of freedom and is controlled by a sophisticated control system comprising motor drivers and an Arduino microcontroller. This system is integrated with the Z-Box, serving as a mini computer to detect mushrooms and execute path planning. The other section utilizes pneumatic technology powered by an air compressor to generate the vacuum pressure required for the soft cup end effector.
We conducted a series of picking test experiments to evaluate the precision and performance of the integrated system. To assess the effectiveness of the trained model, we used metrics such as precision, recall, and mean average precision. Our results indicated a precision of 91.9%, a recall of 93.6%, an F1 score of 92.7%, and a mean average precision of 97.1%. These values demonstrate the effectiveness of the model training.
So you can see 2 stereo cameras attached to the top, which is looking perpendicular to the surface, and a LiDAR sensor mounted over 2 degrees of freedom. We are collecting the data and moving this robot in cruise mode to collect stereo and LiDAR data for peanut crop row. Similarly, this can be replicated for cotton also. In cotton, you can see with this particular speed, we can get high quality data without any jerk or noise, and the motion is smooth. Segment crop, broadleaf and grass type weed. So here you can see it is clearly distinguishing, segmenting the regions of grass weed, broadleaf and peanut. Using the 3D Gaussian splatting for the cotton's row segment, you can see it is highly detailed even in the leaf level. Next, we are using it to visualize cotton rows with herbicide injury, and you can see the details of injury in using 3D Gaussian splatting.
Switching over to the joystick tab allows the user to connect to the server and give full control of the Amiga's movement. To do so, the user must first select the idle button. Utilizing a UDP communication protocol, this button performs a handshake connection from the client, in this case the tablet, to the server, the Amiga. This communication system took many iterations to develop, as it needed to function without slowing down other processes. The neural network-based object detection system, based on convolution neural network layers, fills the role previously filled by the blob detection system. Navigating to the features window, we can see that the Amiga is indeed detecting crops. The identified crops are marked by blue rectangles. Next, the Control tab shows the Amiga calculating the control values based on the location and size of crops in an image, and uses that information to follow plant lines.
First step of our solution consists of mapping the environment using the LiDAR's input. An operator manually controls the robot and steers it to create a map of the orchard. Once the map is created, the user specifies goal point. The robot navigates in the rows heading towards the goal point autonomously while looking for bins. If it detects bins along the way, it aligns itself to pick the bin up. Once loaded, it navigates towards the drop-off zone and upon reaching, unloads the bin. Is in another row, our robot has the capability to navigate towards that point while performing the row turning maneuver. Our robot also has the capability to update its route dynamically in case it encounters any obstacle. This occurs frequently in orchard environment where workers are working in close proximity with machines.
So that's the highlight reel. Yeah. We felt that was important to show because of all the time, the energy, the hard work that went into those projects. So thank you for taking 10 minutes, watching that video. And I hope all the students that are tuned in got a chance to see what the other teams are working on, and it continues to inspire them. So with that said, I know we've had a long drum roll. Oh no. Oh, I screwed it up. All right, somebody got a sneak peek. I was a little crazy with the button. Okay, let's forget we saw that. I want to introduce Priscilla Kepke, CEO of F3 Innovate, to come up and represent the judges in doing the awards here.
Hello, everyone. I have the easy and fun job. So first, I want to introduce all of the judges that participated. So first, we have Aman Anand, Senior Manager in Digital and Agronomic Collaboration with Nutrient Ag Solutions. We have Brad Fruth, Director of Innovation with Beck's Hybrid. Julia Franke, Associate Professor of Computer Science with Salisbury University. Grant Johnson, Urban Ag Technology Advisor with UCANR. John McKeon, Director of Organic Integrity and Compliance with Taylor Farms, and Katie Chiapuzio, Director of Environmental Science and Resources with Braga Fresh. I also did participate as a judge, so that was really fun. Thank you. All right, so if you are in the audience, I know not all the teams could make it, but if you are here once I announce the awards, please do come up on the stage because we would love to congratulate you in front of everyone. So first on this slide, you will see our list of awards. And today I do have the pleasure of handing out $25,000 in prizes to our winning teams. We've held these teams on the edge of their seats for a long time. So let's get started, and I know you've had already a sneak peek. So up first, we have the award for Excellence in Safety, a $2,500 award, and this award goes to the team that best integrated safety features in their design and project. Some of the judges' comments on this project were, keep striving for this solution as it is parallel to industry at the moment. Really love how you approached each task, how you challenged your skills, learned how to solve the challenge at hand, and deliver a slick design. You are forward thinkers who continue to improve and advance what is possible for these Amigas. And the winner is Team Electrified Slugs from UC Santa Cruz. We have one rep. Do you want to come up? Do you want to say something?
Just a few seconds.
Kat, Sam, Milos, Professor Milutinovich, in sunny Santa Cruz, represent. Yeah!
Awesome. All right, let's keep going. Now we have the award for excellence in sustainability, also a $2,500 prize. Now this award goes to the team whose project best addressed environmental concerns. And here are some things that judges said about this team. Very thorough approach and assessment of the multiple challenges tackled in this solution. It has a clear client use case and based on the data provided, performs well. I'm impressed you were able to pack so much into your Amiga. I hope you can continue this project and use this experience to advance the industry. And last one, I believe your accuracy of the plant measurement is superb and the visualization of your plant identification really sold me on what you are doing. Awesome. So the winner of this prize is Team TAMU NCSU Robotics from Texas A&M and North Carolina State University. Do we have anyone? Would you like to speak on their behalf, Kelly?
I will. I'll say, go Team TAMU. Good job, guys.
Okay. So next, we have the award for excellence in small farms technology, and this is a $5,000 prize. So again, some judges' comments. I think your results for autonomous navigation are the best I have ever seen in similar projects. I have witnessed increasing influx of investment in this segment. I think you are looking at a commercial product as it stands currently. The LiDAR visualization in your video submission was really eye-catching and impressive how well you have coded your Amiga to identify obstacles. All right. And the winner is Team Bin Haulers from Washington State University and Heritage University. Oh, we have a rep.
I just want to say thank you to everyone who was with me in the team, putting up 3 months' efforts into this, and go Cougs.
The other winners have hats too. That was my job. I forgot.
All right. So where were we? All right, so next here, we only have 2 awards left. So these are the top 2 awards. So the next one is Excellence in Productivity Award, which is also a $5,000 award. And this is awarded to the team that produced a viable, market-ready solution. Some comments. I'm impressed by the amount of work behind this project. Every forward-thinking ag company desires the capability of automated phenotyping. This is exactly what you created, and I can see this being directly adopted in the ag industry. Seeing the accuracy of your plant counting was incredible, and I'm ready for my growers to use your Amiga as it currently stands. There's some great comments. So, the winner of this prize is Team FloraBot from Auburn University.
You're going straight to the picture.
Oh, they want.
I would like to thank my team, our lab mates, Department of Biosystem Engineering, especially our advisor that put us in a situation to do this.
And War Eagle.
All right, this is it. This is the last and final award for this year's competition, and it is a $10,000 grand prize. So we do have to give credit to all the winners so far. The final tallies were very close. And so here is praise that set out our winning team, set them apart from the rest. I truly felt that this group engaged with their stakeholders every step of the way. They seemed passionate to fix real on-farm problems, and I loved reading about their journey in detail. Really great job with tackling the challenges you encountered along the way, finding solutions with limited resources, and the ingenuity of working through each step and component to come up with a way forward. What an incredible report to read through, and what an inspiration to witness so many technologies working together as one. The organization and level of effort is clear, with a strong impact in addressing the needs of the industry. And finally, a great solution for a very common problem. I like the idea of weeding without chemical product. So next, here we go, drum roll. Congratulations to Team Phoenix Bot from Olin College of Engineering.
Thank you very much. I'm the advisor of the team. And so I just want to say shout out to the 20+ students who worked on this for the last 8 months, working really hard. So all the best. So excited to see the work, get recognition in this way. Thank you very much.
All right, so we're not going to waste any time. We're going to pivot, and we're going to go to the announcement of this is the start of year 3. So I hope the energy in this room has inspired people to get involved, whether you're a student, faculty member, a company that would like to partner with us on this journey we're launching today. Our website has been updated with all the latest information, so go check out the link. Really looking forward to year 3. So we have some interesting developments. So we're expanding a little bit outside the US. We have teams from the UK and Australia that are going to participate next year. Yeah, a little more competition. I do want to light a little bit of a fire with the local folks here in UC Davis, who was the winner of the first year. So yeah, there's a representative here today. So UC Davis won the first year, Olin College the second year. UC Davis has 40,000 students. Olin College has 350 undergraduate students only. So come on, UC Davis, let's see what you got. Yeah. So we want to launch year 3 off with the bang, and I want to bring Nathan Dorn up on stage here. He has a special something to do that, so come on up. Actually, not just Nathan. Let's get all the UC A&R team on stage, as well as APHIS. Steve, I see you there. Not sure if Kristen is here. And if we can get the PharmNG folks up as well.
Briefly, thank you guys for hosting me here. I'm Nathan Dorn, as we said, and this is PharmNG, the APHIS team, the UCA and our team. These are all people that are making it happen. And this is really about not just today's farming challenges, but what it's going to be like tomorrow. Who are the people that are passionate about this? Who are the people that care most about your future? We're adamant about not just the college students and those professionals that are really smart. We're adamant about inspiring the young kids that are coming through high school and looking up to the next generation of people in the farming business. They imagine this as a different world than what we have today, without chemistry usage, with less labor, and with everything possible. PharmNG is really proud to be a part of this and had the opportunity to be there when it started. And so what we'd like to do is continue this by kicking off next year's challenge by adding a little bit of money to the prize pool. So this year the total prize pool was $10,000, and we'd like to present a check for it was $25,000 to start. We're going to present a check for $10,000 just to the Farm Robotics Challenge, so that next year we can get this pool up and more schools are from around the world involved. Thank you, guys. Thank you again.
Thank you, everyone, for coming.
That's a wrap. Get fired up for year 3. Thank you.
Oh, where is my... I had something here. Hey, it's not finished. Please stay in the room. Don't leave. Only 2 minutes left. We have a big announcement to make right now. So if you're not in the room, you won't know. Right? Okay. I have to call on stage our amazing, powerful, I don't know what to say, our friends now that are the co-organizer of this great event that is FIRA USA. I want to call on stage Gabriel Yutzi from UC A&R and Wolji Flock from Western Goras.
Start? Your show. All right. Well, thanks for sticking around. This has been a great year 3 of FIRA USA. I don't know who, for those of you who have been to all 3, this is the best yet. So we've grown the program, more companies, more students, more of everything. Great venue. And so we're here to announce that FIRA USA 2025 will be right here at the same location next year. So we don't have a date yet. It's going to be in October. We're finalizing that now, but we invite you to come back. It gives us an opportunity to optimize operations here and make it bigger, better for everyone involved. So please join us next year. Thanks for being here this year, and we're so excited. Thank you. Walt?
No, couldn't have said it better, Gabe. We had a great time this week hosting everybody, and we learned 2 things. Robots keep getting better, and fairgrounds are a perfect spot to have FIRA. So great to be coming back next year. Thank you for coming this year.